Hi everyone, this is Virendra from iDeserve. Today I'm going to talk about longest palindromic substring in order of n using Manacher's algorithm. So given a string S, we need to find out the longest palindromic substring in order of n. For example, if we have a string like this ABA, BA, BA, the longest palindromic substring of this is the whole string. Okay, we have multiple palindromes here, ABA, BAB, ABA, and so on. But we want to find out the longest palindromic substring. Okay, we have already discussed the dynamic programming based solution for this particular problem, which is order of n squared. Please check that video out. For now, we'll go ahead and discuss the most efficient algorithm for this, which is Manacher's algorithm. Other than dynamic programming, there is another order of n squared algorithm where we expand around the centers to find out a palindrome. Okay, so each character is considered as a center, and the gap between the characters is also considered as a center for even palindrome. So for example, we start with A, we find out the palindrome length for that, then in between A and B, then find out the palindrome length for that center, and so on. We do that till the end. Once we have all the palindrome lengths, we'll take the maximum of the palindrome length array, and we'll know which is the largest palindromic substring. But this is order of n squared, right? Because we are expanding at each center that we encounter. Our goal is to go from order of n squared to order of n using a few clever insights that Manacher's algorithm uses. The first insight is obviously expanding around the centers. So if we consider A as the center and expand around it, we'll find a palindrome of only length 1, okay, one character. If we go ahead and put a center in between A and B, we won't find a palindrome because A and B do not match, okay, given this as the center. If we go ahead and consider B as the center, we'll find a palindrome of length 3. The next center is the empty space between B and A. Again, the palindrome length is 0 here. If we consider A as the center, we'll find a palindrome of length 5. If we go ahead to B, we'll find a palindrome of length 7. Now let's take a thinking pause. Current algorithm is order of n squared. We want to go to order of n. What is hurting us? Expanding around every center is hurting us. What if we cut down the number of expansions? We need to understand the concept of palindrome even better to do that. Let's assess our progress and see where we are at right now. Okay, we have expanded all the centers all the way till B, and we have lengths for palindromes for each center along the way. Considering A as the center, we have a palindrome of length 1, and B as the center, palindrome of length 3, A as the center, palindrome of length 5. Okay, and for the rest of the centers, A, B, A, we don't know the palindrome lengths. Right now, I'm omitting the centers in between the characters just for simplicity. Now let's just concentrate on this center, which is B, second last character, and try to figure out its palindrome length by not expanding. To do that, we will look at the palindrome centered at this point in a different manner. Let's look at it in a different perspective like this. What we see here is palindromes are symmetric at the centers. That is the second insight that we are going to use. Okay, since they are symmetric at the centers, the left part of the palindrome looks exactly similar to the right part of the palindrome. That is the definition of the palindrome, right? So that is what we are going to use to cut down our expansion. Okay, so you see here every character on the left hand side is mirrored on the right hand side. Since the characters on the left hand side are mirror images of the right hand side, what we can do is we can directly copy the mirror lengths towards the right side. Okay, so what would be the length of the palindrome here? If you look at it without expanding, just look at it, don't execute an algorithm, just look at it. You see that at this point the palindrome length is 3, right? And what is here at this point? It is also 3. Instead of expanding here where we have a question mark, instead of expanding here, we'll directly copy the palindrome length from the mirror center to this center. Okay, let's look for this center, which is the last character. What would be the length of the palindrome here? 1, right? We just copy from the mirror center. Okay, now for the character A here, what would be the length of the palindrome? 5. We just copied it from the mirror center. Okay, so are we done? Have we considered all the cases? Is reusing the palindrome length at mirror center enough, or do we need more work? Have we reached order of n? These are the questions that come to mind, right? The answer to all of these is no. Let's assess our progress again. So we have a palindrome centered at this point of length 7, which has a boundary here, the left boundary, and the right boundary here. Now suppose that this string can be extended from the left as well as from the right. Okay, let's see where we are at without the extension. Without the extension, we had the palindrome lengths of 1 at the first character, 3 at the second character, 5, and so on. What if we had one more character after the right boundary? Now let's look at this whole string in a different perspective. The question arises, are the lengths that we copied from the mirror center correct? Are the palindrome lengths correct? I don't think so. Okay, if you add one more character at the right boundary, these lengths change. So if you consider A as the center, the actual palindrome length for A as the center is 3, which is greater than 1. Okay, and if you consider B as the center, it is definitely greater than 3, which is equal to 5. Okay, now let's take a thinking pause again. The length of the center on the right hand side is greater than or equal to length of mirror. It is not just equal to, it is greater than or equal to. So once you copy the length of the mirror, you have to start expanding from the end of that length. Okay, so basically once you have 3, you know that the palindrome centered at B is at least of length 3. That's why we start comparing from the ends of that particular mirror length that we copied. So we just compare B and B, we don't compare A and A, and then we get a length of 5. Now let's jump on to the another case where we expand the left boundary instead of the right boundary, and we know what character is after the left boundary. Let's switch this B here. What happens now is the lengths on the left centers of the main center are greater than they were. So for A here, it expands beyond the left boundary. For B, it also expands beyond the left boundary to length 5. Similarly for the center A. But by the first rule, we need to copy these lengths towards the right side, right? Are these lengths correct? Let's see. Considering A as the center, we see that the palindrome length centered at A is 5. So it is at least 5, not 7. Similarly for palindrome centered at B, it is at least 3, not 5. Why is this happening? Because we never know what character would be after the right boundary. We have to expand and look at it. Because palindrome is not symmetric beyond the boundaries. It is only symmetric till the boundaries. That's why the lengths of the palindromes at the right hand side are at least till the end of the boundary. Okay, so how would we get this length? We'll count the number of characters from the right end to the center, including the empty spaces. So what is the count from the right boundary till this center? It is 1, which is basically the right boundary minus A's index. Okay, just bear with me for a moment. This is a little tricky. Okay, and now for B, how do we get 3? We count from the right boundary till the B's index, which is basically R minus B's index. And for A, we have another empty space here, right? We count that as well, and the A's index. We get R minus A's index equal to 5. Okay, now this looks very abstruse, right? Now imagine at this center the palindrome is folded. Okay, a palindrome of length 3 is folded. What you would say is, if you fold at the center, you will get BA. A is placed on top of A here. Okay, if it is folded, you count the empty spaces as well. It will give you the length of the palindrome. At each center, how do we unfold and count the number of characters in the palindrome? We just count from the right boundary, including the empty characters. Okay, that's how we know the least length of the palindromes on the right hand side centers. Okay, so for this particular center, we have the count as 1, 2, 3. So that is the length of the folded palindrome. If we unfold it, we'll see that it is ABA. Okay, fold it, it will look like this. Unfold it, it will look like this. Okay, we are counting from the right boundary. That's why we'll have r minus that particular center's index. Okay, again in this case, this length that we get, which is right boundary minus the center's index, is the minimum length that we have for that palindrome. Okay, so basically we need to expand beyond that length. Okay, now let's summarize whatever we learned in two simple rules. Okay, assuming we are in this state where we found a palindrome of length 7 and we are trying to find the length of the palindrome centered at here, and we know that the mirror is here. What are the two rules? If the length of the mirror here on the left hand side expands beyond the left boundary of the main palindrome, what we are going to do is we are going to update the length of the palindrome at this center equal to r minus b's index. The other case is if the length of the mirror here is within L, what we are going to do is we are going to update the length of the palindrome at this question mark at b is equal to length of the mirror. Okay, we just copy the length of the mirror here. Once you know which case it is and update the length accordingly for the palindrome on the right hand side center, you will expand beyond that minimum length from 1 and 2. Okay, and that's how you find the actual length of the palindrome at that particular center. These are the three rules of Manacher's algorithm. That's it. That once you understand these three things, the whole code is pretty easy. Okay, let's go through the code of Manacher's algorithm. What we are going to do is we are going to transform this string into another string like this by adding hashes in place of empty spaces, just to consider the case of even length palindrome. And we have some characters to demarcate the start and end of the string. We also have an array which tracks the lengths of the palindromes at each center. So here's the code for the Manacher's algorithm. Let's go through it step by step. We'll start with the second iteration where I is pointing here, C is the center of the main palindrome, R is the right boundary of the main palindrome, and mirror is the mirror location for I. I is basically we are trying to look for another main palindrome. We are trying to find next center for the next main palindrome. Okay, so if the length of the palindrome that we find at I as the center expands beyond the main palindrome centered at C, we'll shift C to I. As we go along, you'll see how C is updated, how I is updated, how I is trying to find the new center and stuff like that. So let's go ahead. In the next iteration, I moves forward, considers A as the center. Okay, so first step is before even expanding it, we try to find out the mirror for that center. Okay, so what is the mirror for I, considering C as the center of the main palindrome? It will be 2C minus I. Okay, if you work it out, you will understand that for C as the center, mirror for I would be 2 into C minus I. Okay, once we have the mirror, the next step is to see if I lies within the boundary of the main palindrome. Okay, does I lie within R? No, right? So we can't apply two rules that we discussed about updating the least palindrome length from palindrome mirror or updating it from the right boundary, which is basically R minus I or P of mirror. Okay, we can't do that because it doesn't lie within the boundary of the main palindrome. Okay, so this case fails. Next step is to try to expand by comparing the characters around the center. Okay, so we see that the characters match. So the length of the palindrome centered at I, which is A, increases, right? Which becomes 1. Then we try to expand again by considering these characters. Okay, but these characters do not match, so we move on to the next condition. Now since I has moved beyond the main palindrome, which is centered at C, we move C to I. Okay, so basically the palindrome centered at I plus the palindrome length at I, if it is greater than the right boundary of the main palindrome, which is R, we shift the center C to I. Okay, we shifted the center here to I because I expanded beyond the main palindrome. since we shifted C, we have to shift the right boundary of the main palindrome because main palindrome has moved out now, right? Okay, so by now you might have understood that I is trying to find the next center of the main palindrome and C is the main palindrome that is into consideration right now. Okay, so let's move on to the next center that we want to consider as the main palindrome. So I moves here. As soon as I moves, we figure out where the mirror is, okay, in the hope that we would be able to copy the mirror length to I and expand beyond that. Okay, but does I lie within the boundary of the main palindrome? No, right? It doesn't lie. It lies on the boundary. It should be within the boundary. Okay, since it doesn't lie within the boundary, we can't follow the two rules that we discussed before in the earlier slides. Okay, so we'll try to expand anyway. Here we try to expand and see that the characters around I, which is A and B, do not match. Does the palindrome centered at I expand beyond R? No, right? So let's move on to the next center. Next center is B. The mirror for this would have been this character. Okay, we don't care about it because I is anyway not inside the main palindrome now. We definitely have to end up expanding. Okay, so while expanding, we compare these characters. These characters are similar, and that's why we increment the count of the length of the palindrome. It becomes 1. Okay, we expand further, compare A and A, and we see that they match. That's why we expand the palindrome again and say that the palindrome is of length 2. Then we try to match the next two characters and we see that they match, and again we increment the count. Okay, so we have found a palindrome of length 3. Now again we try to expand and we see that there is a mismatch between those characters, B and $. Okay, so the condition becomes false and we move ahead to check the next condition. Next condition is, does the palindrome centered at I expand beyond the main palindrome? Obviously it does, right? So we have to move the center of the main palindrome from C to I. So we move it here, okay, and accordingly R also moves ahead. Now we'll also have a left boundary. We don't track the left boundary in the code, but for the sake of understanding, I'm putting the left boundary for the main palindrome. Now let's move I to the next center into consideration. And for this particular center, we have mirror at this point. Okay. Now, since I lies within the boundary of the main palindrome, we can definitely copy the palindrome's length at mirror, which is of length 0. So we copied the palindrome length from here to here. It is 0. It doesn't make much of a difference. Now once we copy that, next thing we do is we try to expand. While expanding, we see that the characters around that center do not match, so we definitely won't increment the count, right? Now the other question is the palindrome at center I expanding beyond R? No, right? So we don't have to worry about it. We don't have to shift the centers. We still have the center at B here. Okay. Let's move on to the next center into consideration. Now since I lies within the boundary of R, we can definitely copy the mirror length here. Once we copy the mirror length, we know that it is of at least this length. So we have to expand beyond this length. Okay. We won't compare hash and hash now. We'll compare B and B. So we compare B and we see that they are the same, so the palindrome expands. So it becomes of length 2, and we try to expand it even further. We find matching characters, we expand it becomes of length 3. Try to expand it even further, it becomes of length 4, and we expand it further, it becomes of length 5. And then we try to match the next characters, we see there is a mismatch. Now we move on to the next condition where we check if the palindrome centered at I expands beyond the boundary R. It does, right? It does expand beyond the boundary R. So definitely we have to move the center to I, right? We move the center to I. Accordingly, we move the right boundary to I plus P of I, okay, which is basically the boundary of the main palindrome. So let's move I to the next center into consideration. I comes here and then mirror is here. So we copy the mirror length, which is 0 here, and then we try to expand, character mismatch, so we skip it. Okay, the next condition there where it doesn't expand beyond R, there is no question of moving the main center. Let's move on to the next center into consideration. The mirror is here, we copy the mirror length. Okay, now we know palindrome center at I is at least of length 3, which is basically this. Okay, so we have to expand beyond this length. We don't have to redo the job of comparing these characters again. We'll start expanding beyond this length by comparing B and B. They match, the palindrome length increases. Again we try to compare the next characters into consideration. They match, the next characters match and again they match. We have a palindrome of length 7, and then we try to match the last 2 characters. We see that there is a mismatch. Okay, the next question is, does this palindrome expand beyond the main palindrome that we had? Yes, it does. It expands beyond R. So we move the center of the palindrome here and we move the right boundary of the palindrome here. Okay, and then we start moving I again to find the next center. Next center into consideration is here, mirror is here. We copy the mirror length, which is 0. We try to expand, mismatch, so we don't increase the palindrome length. It doesn't expand beyond R, so we don't move the center. We move I ahead. Okay, and mirror is here. We copy the mirror length, which is 5. So we have palindrome of this length of 5, and then we try to expand beyond it. We see that there is a mismatch and we can't increment the count. Does it expand beyond R? No, right? So we don't move the center. Similarly for the next center, which we copy the length 3, we try to expand, mismatch, we don't move the centers. Similarly for all the centers on the right hand side. Okay, so mirror is there and we copy the mirror length from here to here and we try to expand beyond it. It doesn't expand, it is a mismatch, so we don't expand, and the palindrome center at this point doesn't expand beyond R, so we don't have to move the center, and we have reached the end of the string. That's the execution of Manacher's algorithm. Please go through the code and let me know if you have any issues or doubts. And about the complexity of this algorithm, I'll give an overview of the explanation of complexity. I'll try to upload another video for the complexity because I don't think it's straightforward to explain right now and it will increase the length of the video. So for the complexity, here if you see, once you have found a larger palindrome, you just walk one by one to the end of the right boundary. Okay, so in the worst case you will do 2 iterations of the string. That's it. You are not expanding every center till the end of the string, right? You are just walking once more to the end of the boundary. So that's why it will amount to order of 2 of n, which is basically order of n. Okay, thank you for watching the video. I know it has been a long video. Thanks for staying patient. Also check out the references that I used for understanding this algorithm. Those references are below in the description. And also let me know if you have any doubts or questions in the comment section below. And finally, stay tuned and subscribe to the channel. I deserve. Thank you.